Hello students, this is the video lecture covering section 10.7, Areas of Circles and Sectors. Our learning goal for this lesson is to be able to find the area of circles, sectors, and segments of circles. So we're going to start with the formula for area of a circle. This is something you should be fairly familiar with. We've worked with the area of circles since middle school. So if you recall, the formula for the area of circle is pi times the radius squared. Tomorrow in class, I'll show you why the formula for the area of a circle is pi r squared in a very edible fashion. So let's start by finding the area of the circular region of this wrestling mat. So before we get started, let's shrink this picture a little bit and move it out of our way. So we're trying to find the area of a circular region. So the first thing that we're going to do is write down our formula. So area equals pi times the radius squared. So in this case, we need to know the radius of this circle. If we look at the picture, we can see here that we're given a number 32 feet. But unfortunately, the 32 feet is the diameter. So we have to recall the relationship between the diameter and the radius of a circle. So in this case, hopefully we remember that the radius is half of the diameter. So we're going to use that and plug this number into our formula. So we have that the area equals pi times the radius, which we have 32 divided by 2 squared. So following the order of operations, we have pi times 16 squared. 16 squared is 256, so we have 256 times pi. And so plugging 256 times pi into our calculator, we get an answer that is approximately 804 square feet. So again, we write down our formula, we take the correct number for the radius and plug it into the formula and simplify. So while you've probably dealt with the area of a circle quite a bit, finding the area of a sector is something that's probably new. So first let's define what a sector is. A sector of a circle is a region bounded by an arc and the two radii to the arc's endpoints. So here you can see we have arc RS and we have two radii, PR and PS. The region shaded in yellow is called sector RPS. We name sectors by using one endpoint, the center of the circle, and then the second endpoint of the arc. So much like we were able to find arc length using a fraction of the circle's circumference, we can find the area of a sector by using a fraction of the area of the circle. So here you can see the area of sector AOB is the measure of arc AB divided by 360, so the fraction of the circle, times the area of the circle, pi r squared. So our second question asks us to find the area of a sector of a circle. So we have a circle with a radius of 4 inches. So let's go ahead and draw a picture. So here we have our circle with a radius of 4 inches. We're trying to find the area of the sector bounded by a 45-degree minor arc. So the next thing that we want to do is cut a piece out of this circle that is bounded by a 45 degrees. So here we're trying to find the area shaded in yellow. Remember, in order to find the area of a sector, we take the measure of the arc, divide that by 360, that's how we get the fraction of the circle, and we're going to multiply this by the area of the complete circle. So we're going to multiply this by pi times the radius squared. First, let's simplify the fraction. 45 over 360 becomes 1 over 8. We're going to multiply this by pi and 4 squared, which is 16. 1/8 of 16 is 2, so we have 2 times pi. And since we're going to leave our answer in terms of pi, we can leave our answer right here. We just need to include the units, which are inches squared. So this sector has an area of 2 pi inches squared. So another new piece of a circle called a segment of a circle. If we were to just Fruit Ninja a slice of this off of the circle, what ends up happening is we end up having an arc and the segment that connects its two endpoints. So that is the definition of a segment of a circle. If we're trying to find the area of a segment, we can think of it as the area of the sector minus the area of the internal triangle. And that's how we find the area of the segment. So here you can see I've labeled A, O, and B on each of the diagrams, and I've put the corresponding radius R. Here we have the formula for the area of the sector of the circle. So we have the measure of arc AB divided by 360 times the area of the complete circle. Here we have the formula for the area of the triangle, which is 1/2 segment AO's length times segment OB's length times the sine of angle AOB. So this is the area of the triangle, 1/2 BC sine of A. Since both radii are the same, we typically write this as R squared. And so what we want to do is we want to take these two things and find their difference. So I'm going to put both of those in brackets. I'm going to plug numbers into this formula to find the area of the segment of a circle. So let's go ahead and take a look at an example problem. So the question asks, what's the area of the shaded segment shown at the right? Round your answer to the nearest tenth. So again, I'm going to start this question by finding the area of the sector as a whole. So that's the measure of arc PR divided by 360, and I'm going to multiply that by the area of the circle, which is pi r squared. So I'm going to plug the numbers in here. So I have 90 over 360 times pi times the radius, which is 4 squared. So the 90 over 360, I'm going to simplify that. And 90 over 360 is 1/4 of the circle. So I'm going to multiply that by pi, and 4 squared is 16. So I have 16 divided by 4, which gives me 4 times pi. Now I know that the question says to round my answer to the nearest tenth, but for right now I'm just going to leave it like this. So let's go ahead and find the area of the triangle. Okay, so remember each side there is 4. So this side is also 4. So I have 1/2 of BC, so both of those are 4. So I have 4 there, times 4 again, times the sine of 90 degrees. So 4 times 4 is 16. Divide that by 2, I get 8. And if you plug the sine of 90 into your calculator, the sine of 90 degrees is 1. So then remember, the area of the segment is the area of the sector, so 4 pi, and we're going to subtract from that the area of the triangle. So my final answer should be 4 pi minus 8. And if you plug this into a calculator, you'll find that the answer is 4.566. So again, rounding to the nearest tenth, this is going to be about 4.6 meters squared. So that concludes this video lecture on section 10.7. Hopefully now you understand how to find the areas of circles, sectors, and segments. Thanks for your attention, and I'll see you all soon.